Hello, everyone, and welcome to this webinar. I'm really excited for the topic we have today on health economics and land use change. Thanks very much for joining us. My name is Pauline Gerard, and I'm the Deputy Director of ISD Experimental Lakes Area. This webinar is part of the ongoing International Association for Ecology and Health webinar series. Today's webinar is on the links between land use change and emerging infectious disease, presenting highlights from the work of the Infectious Disease Emergence and Economics of Altered Landscapes, or IDEEAL project, I love the acronym, which uses economic modeling to explore the costs and benefits of land use change. Our presenter today is Allison White. Allison is an EcoHealth Alliance research scientist who focuses on using spatial analysis and other statistical techniques to examine the emergence of infectious diseases. She also works on knowledge translation projects, communicating scientific evidence to communities and stakeholders. Prior to her work at the EcoHealth Alliance, she spent 3 years in Botswana working on community health and HIV&AIDS services at a rural clinic. Allison holds a BA in Public Health Studies from Johns Hopkins University and an MPH in Global Epidemiology from Emory University. Thanks for joining us, Allison. Before I hand things over to her, I'd like to run over a few ground rules for the webinar. I'd like to ask everyone, other than the presenters, to please keep their microphones on mute during the presentation. Also, we will have a question and answer session after the presentation. When you have a question, please type it into the webinar chat box, and I will read it out loud to the presenter. Our webinar coordinator will demonstrate how now by typing into the chat box. A message should come up in your chat box in just a moment. We'd love if you could include the name of your organization in your post so that everyone can get a sense of who's online. You'll see in the chat box that you can select who can see the question. We ask that you please select all panelists so that only the presenters can see and not all the people attending. If you run into any technical issues, I encourage you to contact our webinar coordinator, Carla Zubricki, who is online today to help with technical troubleshooting. Please contact her privately via the chat box in the webinar software or email her using the address on the screen. One issue that participants sometimes encounter is that their audio disconnects during the webinar and they suddenly can't hear the presentation. If you find your audio drops out partway through the webinar, it can usually be fixed by disconnecting and reconnecting again. If that doesn't work, this webinar software also offers a call-in option, though phone charges may apply. This phone number can be found in the registration confirmation email sent to you by the Zoom webinar software. Carla will stay available throughout the webinar to try and solve any problems that arise. Also, we took a peek at who had registered, and we are happy to see a great variety in the types of organizations that are attending today. We have registrants from 12 different countries representing various governments, universities, and colleges, research institutes, and foundations. Thanks to you all for your interest and time in this topic. Now that we've covered the webinar guidelines and highlighted who is attending, I'd like to pass it over to Allison to share her work with us. Over to you, Allison.
Great. Thanks, Pauline. Thanks, everyone, for participating, and thanks to the IEH for hosting. As Pauline mentioned, my name is Allison White. I'm a research scientist at EcoHealth Alliance. Just to give you a little bit of background, EcoHealth Alliance is a global, a nonprofit organization. We're based in New York. We work in over 20 countries globally, and our research is focused on the One Health approach. So today I'm going to be speaking about one of our multidisciplinary research projects called IDEEAL, which, as Pauline mentioned, stands for Infectious Disease Dynamics and Economics, Emergence and Economics of Altered Landscapes. So briefly, I wanted to go over, for those who aren't familiar, what One Health is and how it ties into emerging infectious diseases. So One Health recognizes that human health, animal health, and the health of the environment are all issues that intersect on a global scale. This ties into infectious diseases because wildlife, livestock, and people interact with each other and with the environment. So a lot of our work focuses on looking at emerging infectious diseases from a One Health perspective. Pictured here on the right is a hotspots map that we developed. We're looking at hotspots for emergence of infectious diseases using biologic variables like mammal diversity, environmental variables like land use change, and human demographic variables like population. We can use this information to target the higher risk areas in yellow for surveillance, for example, at wildlife markets. So that's sort of background on some of the types of work that we do and why we're looking at One Health and emerging diseases. So when we say emerging infectious disease, what do we mean? It's a new disease not seen before in humans. They're a significant public health and economic issue. The majority of infectious diseases are zoonotic in origin, meaning that they come from animals. And most of these, over 70%, come from wildlife, meaning that focusing on wildlife and domestic animals and humans and the environment is important from a disease emergence perspective. Emerging infectious disease events caused by pathogens in wildlife are increasing in impact over time. More than half of the most recent emerging infectious diseases from 1990 to 2000 had a wildlife origin. Furthermore, infectious diseases and emerging infectious diseases can have a major economic impact. So this slide is just showing the economic impact of some infectious disease outbreaks from the past 20 or so years. So you can see SARS, which is in this red bubble here, in China, Hong Kong, Singapore, and Canada, had several $billion impact that extended far beyond the number of cases. And then more recently, you have H1N1 and then other outbreaks such as Ebola. So you can think recently, emerging infectious diseases continue to be an issue. There's an avian influenza outbreak going on in China right now. Over 300 human cases this year have been seen, and it's the 5th outbreak of this strain. It's also having major impacts on poultry markets. These types of outbreaks cause culling of animals and also closure of markets. So what we're trying to do is prevent these diseases from spilling over from wildlife into livestock and humans, so to stop pandemics before they start. So because of that, we're looking at what causes diseases to emerge. And what we know is that land use change is one of the primary drivers of emerging infectious diseases. So this chart is showing some research that we did into drivers of emerging infectious diseases. So this bar at the top is land use change. That includes deforestation, agricultural intensification, so expansion of agricultural areas, as well as habitat degradation and habitat fragmentation. So there are two main hypotheses as to why land use change might lead to this sort of emergence. One is that this land use change leads to encroachment in habitat and increasing contact between wildlife and humans, as well as wildlife and livestock. And that this increased contact leads to increased pathogen spillover from wildlife to either humans or domestic animals. The other hypothesis is that the actual act of land use change impacts the dynamics of pathogen transmission within wildlife, promoting cross-species transmission. And so that, the understanding of the One Health approach, land use change, and disease emergence are really some of the things that have driven the IDEEAL project. So there are two main goals of this IDEEAL project. One is to understand the benefits of keeping intact forests to regulate disease from an ecosystem services perspective. And secondly, to estimate the economic costs that are avoided by reducing deforestation. Because unfortunately, we cannot protect everything, and developing some areas of forest can have benefits, both economically and health benefits. So I'm going to talk now in more detail about the IDEEAL project. There are a lot of components to this project, so I'm going to go through some things pretty quickly. So please feel free to ask questions afterwards, and I'm happy to go into more detail about any of these topics. So IDEEAL, which again stands for Infectious Disease Emergence and Economics of Altered Landscapes, is a project that we've been working on for several years. It takes place in Malaysia, in Sabah, which is a state in Malaysian Borneo specifically. It's highlighted in red on this map. And it was selected for this project because it's an area of a lot of biodiversity and high numbers of endemic animals, mammals specifically. And because it's been the site of a lot of rapid land use change. So around 40% of Sabah was converted from forest to palm oil plantations primarily between 1973 and 2010. Some of that development has been for other reasons, but the bulk of it is focused on palm oil development. And because of that, the focus of this project and the economic analysis is focused on land use change related to palm oil development currently. So just briefly, I mentioned the concept of ecosystem services and wanted to spend a little bit of time going over what we mean when we say ecosystem services. So ecosystem services are really services that we can get from the environment. So we're operating under the assumption that the environment provides certain benefits and that these benefits have a specific value to them that can be quantified. So some of the things they do is provide fresh water, water purification, pollination, erosion control. And key for this project is disease regulation. Policies, land use change, and other factors can impact ecosystem services and impact these values. And these ecosystem services, in turn, have the potential to impact our health and well-being. So, the IDEEAL project, given this background, is focused on 4 main activities. 1, developing economic models to estimate the cost of land use change in Sabah, focused on ecosystem services, including disease regulation, which is unique among this project. Secondly, developing spatial models to inform land use policy to show not only how much land can be developed, but where the best places are to develop. And third, to engage stakeholders via outreach and education. This includes stakeholders across government, industry, policy, and communities. And fourth, to create actionable toolkits that provide specific tools to both policymakers and communities to help inform development decisions. So what we're really trying to do is to do economic and spatial modeling and to use that modeling output and that evidence base to inform decision-making and policy. So why are we using an economic model? There's been extensive land conversion due to palm oil production since 1993. You can see in this chart, it's risen drastically. And land use change requires making trade-off decision makings. So land use can be measured in specific monetary ways. And an economic model allows us to look at the total impacts of land use decisions. So we're really answering a few questions. What is given up when a hectare of land is developed? So you have things like wildlife habitat, carbon sequestration, disease regulation capacity. But you also have gains from developing a hectare of land, including revenue, tax collection, jobs, GDP growth. And oftentimes these can have, particularly jobs and GDP growth, can have major impacts on other sorts of development indicators like access to education or can lead to building of increased connectivity in clinics. So with that in mind, we want to know from an economic perspective how much forested land should be developed and how much should be conserved to maximize the gains from developing land while minimizing the losses, such as loss of carbon sequestration and loss of disease regulation capacity. And then we also want to answer where this land should be developed to minimize those costs and maximize the benefits. Sorry. So I'm not going to go into a ton of detail. This is the economic model that we're using. But the point that I do want to make is basically the way that we're quantifying land value is looking at the gains from conversion, so those benefits from development, combined with the loss from conversion, so the loss of carbon sequestration capacity that you find in a pristine forest, the loss of disease regulation capacity measured in an increase in disease cases, and then a discount to account for looking at that over time. So we've done this modeling and we're comparing our model output with real data to look at how much we should develop conserve. So this green line here shows the current rate of land conversion in Saba. And this black line here is our model showing how much land should be converted over time, considering only ecosystem services values that don't include health. So things like carbon sequestration that I mentioned before, measured in CO2 outputs. So you can see what's interesting is that early on, the actual conversion of land in Saba followed pretty closely what the model output is, and then in the mid-90s diverged wildly. And this section shows, next, we modeled the health impact of conversion. So this dotted line is showing how much land should be converted over time, considering both ecosystem services and health impact. In this case, the health impact is focused on malaria, since there's evidence linking malaria with deforestation and land use change across several continents. So as you can see, once you consider health costs, the amount of land that can be converted from drops. And this is, again, purely from an economic perspective, so looking at maximizing the gains and minimizing the losses. And the other thing that we can see is that, that the rate of conversion in Saba currently has far outpaced what our model projects as optimal. So the third projection that we did is what we're calling the private optimum. And so what this does is it takes away the ecosystem services and health costs and only looks at costs sort of from a private industry perspective for them to maximize a lot of the gains, because ultimately industry players who are sometimes involved in land conversion aren't paying the costs of ecosystem service loss or the health costs of that conversion, at least not directly. But it's interesting what we can see when just considering the benefits and costs of palm oil operations, that the rate of conversion in Saba already has outpaced even that private optimum. And so you can see that 43% of land could be developed by 2150 under the private optimum, while only 24% of land using the ecosystem services and health model. And again, the health model is focused on malaria right now. So really what we've used this economic modeling to show is that thus far, Saba has converted too much land too quickly into palm oil plantations. The second part of our modeling is the spatial modeling that's trying to look at where we should develop and conserve land. And again, just because of time, I'm not going to go into a ton of detail on all of the modeling. But essentially, what this modeling does is it searches for more and less optimal areas to develop palm oil. And it does this based on several different inputs. For example, on the right, I have, there are two maps of Saba that show a couple of different inputs. So on the top, you have slope. So areas with a really steep slope are not optimal for palm oil plantations. You won't have as high of a yield. The trees don't grow as well. And then secondly, accessibility. So accessible areas may be better for development than inaccessible areas. You can also put a high cost and against developing near river areas or national parks, and the model will account for that, and will treat areas that are near existing plantations more preferentially. So this blue square on the right, the red areas are the areas that are more optimal for development, whereas the dark blue areas are the areas where you would say we shouldn't develop or couldn't. So we've also blacked out conservation areas and national parks as areas that are off limits for development, since those couldn't be developed into plantations, even if they're suitable. So what we found is these areas in yellow on the map on the left are the areas that are most suitable for palm oil development, and this is shown an ideal development process over an 80-year span. The map on the right shows current land development in Saba. So the areas in yellow are current plantations. So you can see that actually a lot of the plantations track quite well with what our model projects. However, in the sort of eastern tip of Saba, you can see a lot of development has been happening where it's not optimal, as well as in western Saba. There aren't as many developments, but you can see growing areas of plantations and deforestation. So I want to wrap up with just talking briefly about how we're using these tools. So throughout this project, we've been engaging with government, industry, and communities. We've worked with policymakers, so government at national government levels, state government, as well as local government across multiple sectors, including tourism, economics, health, and environment. We've also worked with non-governmental organizations and community organizations to try and work directly with people who are impacted most closely by these land development decisions. We've also engaged with industry and private sector, because ultimately they're the ones who are making some of these decisions along with policymakers, but who are also seeing some of the impacts because workers in palm oil plantations are some of the people who are going to be in these areas of high land use change and working directly along these interfaces. So what we're really trying to do with our outreach is to explain our spatial and economic models in practical ways and work directly with people involved in decision making to use this evidence in the land use planning process. One way we've done that is engaging specifically with scientific research. So we're working with the University of Malaysia, Sabah, UMS, to establish a development and health research unit. And this unit is based in Sabah. So it's based in Malaysia. It's comprised of faculty there, as well as local researchers, and is in charge of conducting multidisciplinary research across an intersection of topics. So it's not only topics related specifically to this project, but any topics related to health, development, and the environment. So this could be another economic project. It could also be projects looking at communication of health messaging or disease ecology projects. And one of the things that we're working to do with the Development Health Research Unit is to increase links between the industry and policymakers and the research. And we also lead seminars and graduate research through the center. For example, sponsoring several students studying illegal wildlife trade, attitudes toward wildlife hunting, and impact of land use change on childhood parasites. Another aspect of our outreach is a Health Impacts of Land Use Change toolkit, which is a toolkit that we've developed, and it's on human health and land use change. And so it links our scientific findings with action through activities and discussion. We've presented it to leaders and community mobilizers from over 30 villages, and have trained local facilitators to use it in Saba. Its primary goal is for participants to gain an understanding of how land use change can impact health, and also to discuss specific strategies on how to mitigate and reduce the negative impacts of land use change in their communities. So this is something that we're working on now, but I also want to point out that we're using this toolkit not only with communities in Saba, but also with industry stakeholders. So we presented the toolkit at the Roundtable on Sustainable Palm Oil to several industry members, and we'll be doing trainings with some palm oil plantation managers and sustainability managers in the future, with the goal of helping increase the awareness of this as a potential issue to be used in development decisions, and then also hopefully to use the model in the future. So main take-home messages is that there is a link between land use change and emerging infectious diseases that can potentially have large damages to society, both from a public health impact and from an economic impact. And that sometimes these economic impacts can actually be larger than the direct public health impact. Secondly, our data from our economic modeling suggests that Saba has converted too much land too quickly and in the wrong places for oil palm plantations. And that, thirdly, these sorts of One Health policies can increase human, animal, and environmental well-being. So just to wrap up, one of the reasons I wanted to highlight the IDEEAL project and talk about it from a One Health perspective is I think that it's been a really good example of working on a multidisciplinary team with economists, public health specialists, disease ecologists, biologists, to do this sort of modeling, and that the impact of this project is also quite multidisciplinary. So the development decisions that are being made at the government level have the ability to impact other parts of the government, and that's one thing that we found from working really closely with our partners, is that there's sort of an interest in that multi-stakeholder engagement. So those are our take-home messages. I'm going to stop here to give us time for questions. I know this was a lot of information very quickly. But before I do, I just want to briefly take a moment to thank all of our partners. Really fortunate to work with a really wonderful team in the office here in New York, as well as in Malaysia, and have really strong support. So you can see from our acknowledgement slide, we work with a lot of different groups within Saba and within Malaysia. And this program has been funded by USAID's Regional Development Office for Southeast Asia. Thank you.
Okay. Okay, excellent. Thank you so much, Allison. That was really interesting and a great presentation. So just a reminder to all participants, please type questions into the chat box as you have them. So I have one question, the first question from Jamie Atkins. So he asks, can you talk a little bit more about the private optimum that has been discussed with local private industry members, and how do you explain to them that they are past the optimum amount of development, and what's the response?
Yeah, so let me just pull up that slide really quickly. So we have found that industry has been quite receptive to our modeling approach. You know, I think one of the challenges of this project is, from this model, we've shown that even the private optimum rate is lower than what the current conversion of Saba is. There has been a slowdown recently in land conversion in Saba, I think due not necessarily to this model, but just an awareness that at the rate it was going wasn't going to be sustainable. The other thing that we found is that even though I presented this as the private optimum, industry has been really open and engaged in looking at these issues of ecosystem services and health, and particularly the health issues, because as I mentioned before, those are issues that they care about too. I think, one from perhaps a social justice or health perspective, but also too from a workforce perspective, and that they're the ones who are developing these areas of land. It's employees of the palm oil industry who are going into these areas where there is a lot of land use change. And so if there were to be an emerging infectious disease, potentially would be some of the first people to come into contact with these new pathogens. So actually we found that industry has been pretty receptive. We've also been working with industry to get feedback on the model. There is a lot of different inputs in sort of in palm oil plantations and in palm oil extraction. So working with them to incorporate things like taxes, but to also look at making sure that our estimates for the amount of oil produced per hectare encompasses palm oil as well as palm kernel oil, as well as products from other byproducts of the palm kernel oil. And I think that focusing on that sort of increased productivity on palm oil areas is one area the industry is really trying to work for, and there are a lot of really efficient operations now. I hope that answers your question.
I wonder this, oh, he said yes, thanks. I wonder if you can similarly talk a little bit about the community response to the model, or to, some of the arguments that you're making. And then you talked in your outreach work how you're trying to get them to identify strategies to address these issues. And so what are strategies that communities are coming up with?
Sure. So I think, with the community work, a big focus of it is on, really talking about the One Health approach and how land use change and health are linked, because it's not something that's necessarily intuitive, and it's not something that I think a lot of people are aware of. And I think, but what I think we have found is that particularly communities in these rural areas who are living, in or near the forest, understand ecosystem services much better than, maybe not much better, but immediately are able to understand the importance of them really quickly, because some of these communities are directly benefiting from some of these ecosystem services in terms of actually being people who are going out into the forest and gathering food there, in a way that folks in more urban areas tend not to. So in some ways, it's really more of providing this sort of framework and terminology to talk about these issues. In terms of strategies, I think, the biggest strategy that people have talked about is really focused on policy change, but how potentially you can look at policies from a really local level as well. So to focus on both national and local level policies, so do top down and bottom up. But yeah, so what we found from communities in terms of developing strategies is is kind of focus on the micro level. And a lot of communities, I think are pro-development, to an extent, like want increased connectivity and want some of the jobs and economic benefits that come to them development. And so, really just want to have that balance of having those benefits, but not ignoring the costs and the losses, and having that sort of policy measures to mitigate that, be that increased clinic services and awareness, or better wildlife contact handling measures, or policies surrounding development.
And then this is Pauline again. In terms of the other kind of big stakeholder, I'm interested to hear what the more traditional kind of health organizations think about this research, because it's really interdisciplinary, and in some ways I can see it being quite outside the box for more kind of traditional health work. And so I'd just be interested to know what people are saying in those groups.
So I think that particularly for traditional like medicine and public health, it is a little outside the box. So I think, it has taken some time to explain the One Health approach and why we're using an economic model, and that, we're not showing what's best from any other perspective than an economic optimum. But I think what has been really advantageous, and what some folks at government have really bought into, is that the advantage of having an economic model, particularly in government, is it gives you a cost framework around which to talk. So for example, there's a ton of money spent on spraying for dengue, on preventative health measures for dengue every year. And those are costs that come out of the health department or Ministry of Health's budget. So we're talking about it from that perspective, and they're like, oh, we have seen dengue cases increase. Dengue has been linked to land use change and urbanization. So talking about that, I think that's been a really effective tool for governments and for health departments too. And be like, we could be spending all of this money on other things if we weren't seeing this huge uptick in dengue cases. And, to consider if it's related to land use change, and if so, for them to have an economic argument to press for example, stricter enforcement of fines against, at construction sites, against standing water and other places that can be mosquito breeding grounds. So I think having the economics in there can sometimes help move things along.
Yeah, that makes a lot of sense. I find I think it's excellent work. Like, it's really, really interesting. And I love how interdisciplinary. It must be fun to have such a variety of different people from different backgrounds together trying to work on one common problem. I love it. That's great. So I don't see any more questions in the chat box. Unless anybody has anything that they want to add, please add it now. I'd like to point all participants to a survey that we've asked, that we would love your feedback on your survey experience. We did have a few technical problems with people having trouble getting on, and we're trying to figure that out. So I apologize if anybody had trouble getting onto the webinar and ended up getting on late. Will it be recorded? Yeah. It is being recorded and will be posted within a day on
YouTube. I'll send the link.
We'll send Carla. The link will go out to Carla, to everyone who registered for the webinar. So once again, thanks very much, Allison, and EcoHealth Alliance. We really appreciate your time and all the work that's going on.
Thank you. I hope this was informative for everyone. You're welcome to reach out to me if you have any other questions, or you can find more information on this project and other projects at our website, which is just ecohealthalliance.org, for some more background reading. But thank you guys so much.
Thank you too. All right, everyone have a good afternoon. Bye.
Bye.